creating encrypted volumes with TrueCrypt. I'd like you to imagine, just for a moment in your mind, what your most sensitive documents are that have the most sensitive information that's on your computer right now. Then I'd like you to imagine what would happen if somebody stole your computer and was able to log in successfully. How devastating would that be? For most people, that would be really, really bad news. In this nugget, you and I are going to take a look at what we can do in measurable terms to create encrypted portions of our file system to store those sensitive documents so that if our computer is stolen, they won't be able to get to those documents even if they have full access to the file system. Let's begin. Our objective in this nugget is simple, is to identify how you and I can protect local files on our computer with encryption, so that if anybody does get a hold of the file, they won't be able to do anything with it because they can't unlock the mystery, if you will, of the file because they don't have our passcode for that individual file. Now, why would we need something like this? Let's talk about that for a moment. What's the benefit of locking up a portion of our file system with encryption? Well, the answer is Bitcoin wallets. Now, we might have on our computer our own Bitcoin wallet. So there's lots of options, and I'll share more with you as we continue in our journey together. But let's say we're not using blockchain to store our e-wallet. We're doing it on our local computer. So what exactly is a wallet file? It's just a file. If somebody steals that and is able to use that wallet file, they could then go ahead and transfer Bitcoin out of our wallet. That's not a good idea. We want to keep the private keys, which are the most important part of our wallet. We want to keep them secure. So maybe we want to secure our Bitcoin wallet. And that, my friends, would be a great, great reason for us to encrypt a file on our computer. Now, another thing that we might have on our computer is we might have a password file. If you do have a password file, hopefully it's encrypted in some fashion. Why is that? Let's say we have 100 passwords to remember. And of course, we don't want to use the same password everywhere. How do you keep them straight? Well, there's a lot of really cool utilities that can store your passwords. But let's say you have them in a password file. There's two things I'd like to share with you about that. Number one, let's say you have a passphrase that's part of all your passwords, like zebra. So maybe on one site it's zebra, 1, 2, 3, 4, 5. And another site it's zebra, ABCD, and an exclamation mark and so forth. What you could do in your password file, if you're going to keep one, is never write down the word zebra. Go ahead and put like X, 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 5 characters. And that way it would represent to you the word zebra, but never write that down. Never tell anybody that's your passcode. Now, on top of that, this password file, if you're going to store it, it should also be encrypted. So what we're about to learn is how we can take portions of our file system using some open source free tools and encrypt that file. So in the case of somebody unfortunately stealing either our files or stealing our computer, that person, if they brute forced their way in and they figured out how to log in as an administrator or similar on that computer, they still wouldn't have the ability to unlock a specific file or files if we had encrypted them. So there's a lot of benefit to be had by you and I in encrypting a portion of our file system. Encrypting part of our file system is a wonderful thing. However, we also need to take advantage of other tools. For example, we should probably be running some type of firewall software. Now, most operating systems have some type of firewall system built into them. We just need to make sure it's enabled. Like, for example, Mac OS has it. Most flavors of Windows have it. So firewall software, if I have a PC right here, and that PC currently is just sitting on the network, so he has a network connection. If somebody tries to open a connection or pings this device or sends traffic into it, firewall software would say, hey, you know what? I didn't request this. I'm not going to accept this incoming connection to me. Or perhaps maybe there's some software running on that computer, and that computer is trying to go make an outbound connection. That's not something that you wanted to have happen. Some malware or some Trojan horse software is running, it's trying to make outbound connections. Firewall software can identify that and stop it. Now, is all firewall software created equal? The answer is no. You definitely want to do some due diligence and get one that's popularly accepted as being very, very good and use that. So I'm not going to make a specific recommendation in this nugget because there's several really good vendors to choose from. Just get one that's reliable, that you've heard of, and there's also a lot of free options as well. One word of caution I would ask you is that don't just go out and download the first free, firewall or antivirus, anti-malware software. Do a little bit of research with Google, because you definitely don't want to say, oh, that looks really good. You download it, and maybe you got it from a malicious site, and you installed some type of a rootkit or keylogger or something else that's going to harm your system. I would go for a mainstream, well-accepted antivirus firewall, anti-malware type of application. So antivirus should be updated periodically. If you have it done set for automatically, that's great. And a lot of vendors like Microsoft have things like the Microsoft Safety Scanner that can go through your system and try to find keyloggers, other malicious software and so forth. There's Security Essentials also from Microsoft. So there's a lot of free software that's included with many operating systems. We definitely want to make sure we're taking advantage of all those features that are already in or available on the platform that we're using. Now, the second thing I'd like to share with you about improving our security posture overall before we do encryption is this really amazing tool called OpenDNS. Now, back in the 90s, when I went to a conference, it was back, the network wireless cards were a brand new thing. So I had this huge laptop running at Windows NT, and we checked out these wireless adapter cards, and we plugged them in, so we had wireless all through the conference. It was very, very new at the time. So we were on the wireless network, and I thought to myself, I wonder how hard it would be just to make myself a DHCP server and hand out, IP addresses. And the answer was, it was just a couple clicks, and poof, I'm a DHCP server. And I thought, well, if I'm a DHCP server, I could hand out anything. Like I could hand out the wrong default gateway information. I could point to myself and be a man in the middle. I could point out the wrong DNS information. I could feed back incorrect DNS information to clients. So of course, never do anything like that. I didn't do anything like that, of course. But I want to point out the fact that it's completely possible. And so with DNS, we want to make sure we're not being lied to with DNS by using OpenDNS, which is free. If you're a home user, you've got kids, there's other parental controls as well with that. I would strongly recommend you look into OpenDNS.com. You can go right there for all the information on that. But by doing so, you're going to make sure that your PC, when it makes a DNS request, isn't getting lied to about the actual website to go to, and you're being redirected to some other nefarious application. So now that we've taken a look at making sure we have some basics in place like firewall software, antivirus, anti-malware, etc., and I strongly recommend using OpenDNS so you're not lied to. For example, with OpenDNS, let's say we have a website we go to all the time, and we go to that website and we log in, and unfortunately it was redirected to another website that looked like the website we were familiar with, and we logged in, or we thought we logged in. Guess what? They now have our username and password just because they redirected us to another location. Now, looking at the SSL certificate and other things can be helpful in identifying that, but the reality is using OpenDNS will help us avoid being redirected to a different website in the first place. So let's focus now on TrueCrypt. What exactly is TrueCrypt? TrueCrypt is an open source free software. It's made for a Windows. It's also made for a Macintosh platform, and here's how it operates. What we're going to do is we're going to identify that we want to create this new logical volume. So let's say, for example, let's take Windows. So we have Windows, and on Windows we've got, let's say, the C drive, and maybe we have a CD-ROM as D, and we have a whole bunch of other drive letters. So E all the way through Z. And if you're on a network and you have some map drives, you may have some of those tied up with map drives. What we're going to do with TrueCrypt, we're going to install the software, which is really painless and very quick. And then we're going to say, we want to create a brand new volume. So you pick a spot on your file system. Let's say you currently have the F drive as an example. And maybe it's an external drive. And on that F drive, you're going to make a folder called temp. It doesn't really matter. I wouldn't name it anything specific. For example, I wouldn't name this folder TrueCrypt. This is where my encrypted stuff is kept. And then you specify in the software a file name. So let's call it temp.dat. You can call it anything you want, any valid file name in the operating system you're working on. That's great. And when you create that file inside of TrueCrypt, it says how big do you want this to be. You're going to create this logical volume. Let's say we're going to create drive X. So the file is pointed right here. We say, for example, it's 10 gig. Now that's pretty big. 10 gig or 110 gig. That's big. That's a lot of space. But the benefit is the bigger your file is, the harder it's going to be for somebody to steal that file, for example, electronically by copying it off of your computer and putting it somewhere else. Now, even if they copy this file represents a new volume. So we could have it be the X drive. So we're going to have it create this file. We're going to say it's 110 gig, or let's say it's 10 gig, or whatever size suits your needs for whatever you're going to store there. And then it creates it. And then you're going to go ahead and specify a password that unlocks it and allows it to be mounted. And then we can have it mounted as any drive letter we want. So we can say, okay, this is going to be the X drive. And the X drive, once we launch the software, we mount this volume, that X drive is just like another external drive. It's really pointed at that single file. Anything we write to it is automatically encrypted. Anything we read from it is decrypted so we can work with it. And then when we turn the computer off, that file is just a file. It's going to be 10 gigs in size. And the benefit is that it's totally encrypted, meaning somebody who steals the computer, if they do brute force login, they see this file called temp.dat. They don't know exactly what it is. Even if they do know what it is, they aren't going to have the keys, if you will, to unlock it or to decrypt it to figure out the contents inside. So on our X drive, once this file is mounted as a 10 gigabyte volume, we can store anything we want in it. And here's another benefit. Let's say you have this up on Dropbox. I know a lot of people store a lot of stuff on Dropbox. So if somebody does steal it from Dropbox somehow, perhaps there's a legal government request to go in and seize some files. They grab this file out of your Dropbox account legally based on the law, and they can't open it because it's encrypted. So they'll have this file, but they won't have the contents of that file to help improve your privacy. Now, if this is the only place, for example, that you stored your wallet, you're still in trouble because now you don't have your keys either. So it's very likely that we're going to create a couple of these, maybe on a couple different computers to store our actual files. And that way, if we lose one computer or one file system, we have a backup, but they're encrypted at both locations, and that would be preferable. So with that being said, let me walk you through the steps of installing and using TrueVault to encrypt your own private volume. One of our first orders of business would be to go up to TrueCrypt.org and actually download the software. Be very careful as we download the software, making sure we're getting it from a reputable site. For example, if there's a malicious group who wanted to have people use TrueCrypt, but yet they got the code and they integrated some kind of a backdoor or keylogger or something else along with it, that would make it not so secure for us to use, especially if there's a keylogger recording the passwords that we're using inside of it. So we're going to download TrueCrypt right from TrueCrypt.org and install it. The install is pretty much a next, and it's installed. And once it's installed, we can then use it to create our new volumes and begin using them. So now the fun begins. We're going to create a brand new volume. It's going to be that file that ends up on our file system somewhere, but our operating system is going to treat it as a volume that we can mount and then use. So let's go ahead and click on Create to create a new volume. And if you accept the defaults, it'll work. There are a lot of additional bells and whistles that you can use, like encrypting a partition or an entire physical drive. We just want to take one single file, which is the default, this top option here. We'll click on Next. It then says, you want a standard TrueCrypt volume or do you want a hidden one? So you can get even more devious. You can have a TrueCrypt volume that when somebody looks at it, it appears empty or it appears like there's some files there, and those files are just noise. They're not really important. And then you have another hidden volume that you can use as well where your really important data is, hopefully to avoid somebody forcing you to give the password to log in, forcing them the password for their TrueCrypt, and then they wouldn't know that there's a hidden volume hidden behind it. So there's lots of additional options. Let's go for the standard. Click on Next. It says, great. What file do you want to use to make up this brand new volume? We'll choose one together by simply clicking on Select File right here. This opens up our file system, and I'm going to go to my F drive. This happens to be an external drive. I keep a lot of GNS3 and some other stuff there. But as an example, let's create a brand new folder. So I'm going to say, I want to use a new folder. I'm going to call my new folder Working. Now it's just a name. You don't even have to put it in a folder. I like keeping it in a folder so I can find it easier, but I'm just going to create a folder called Working. You could call it anything you'd want. And then I'm going to create a file. The file name, I'm going to call it family.mov. Now, why am I going to call it MOV? It doesn't really matter what the extension you give it. I just want to make sure that it's nothing that's too obvious regarding, for example, I wouldn't call it TrueCrypt.dat. Somebody who's looking for something sensitive, they might see that. Or I could call it, I wouldn't call it anything interesting. So let's call it boring.mov. So it's going to be a huge file, and the MOV file is pretty large, and hopefully that somebody sees it on our computer, they won't draw attention to it. So I'm going to call it boring.movie. I'm going to keep it in a working folder on the F drive, and that F drive happens to be called GNS3. So I'll click on Save. It says, great, that's your file. Click on Next, and it's going to say, what type of encryption do you want to use? AES is absolutely wonderful. There's additional options here, but the advanced encryption standard is fantastic. And then we can go ahead and simply click on Next. You can also choose a different hashing algorithm if you want to. The defaults work perfectly fine. Click on Next, and now it's saying, okay, how big do you want this drive to be? Now, it's a 2 terabyte, I have a 2 terabyte drive, and I've got lots of space available. I'm just going to make a, let's call it, how about a 2 gigabyte file. So this file will turn into a 2 gigabyte volume. Now, this really depends here on how much stuff you're going to keep in it. If you plan on keeping 4 or 5 gigabytes worth of content, you might want to make it bigger. So, in fact, I think I will. I'll make it 10 gigs. So I'll make it 10 gigs, and I'll click on Next. And it says, okay, I need a password. Now, this password is important because every time when we boot up the computer, if we want to mount this file as a logical volume on the computer, we need to use this password each and every time we boot up the computer and then want to mount it. So you want to have a secure password. And here's some great recommendations. Longer is better. Alphanumeric characters, special characters, uppercase, lowercase, passphrases, 2 or 3 words put together with special characters inserted. Make it tough for somebody to just simply brute force try to guess what the password is. So having said that, I'm going to use a password that I can remember for this demo. It's just a temporary file. I'm going to delete it afterwards. And then I'm going to go ahead and click on Next. I use password, by the way, for my password, which is also a very terrible idea. That'd be one of the first ones guessed by somebody trying to do a brute force attack against it. But I can type it in for the demo. It's going to work great. So it says, okay, warning, Will Robinson, your short password's weak. And I'm going to say, I appreciate letting me know that. I'm going to continue forward for this demo. And then it says, do you plan on storing any files greater than 4 gig on this TrueCrypt volume? And it needs to know for the type of file system it's going to use. Now, if you're going to be using the same volume across different machines, maybe on a Macintosh and the same exact file over on Windows, maybe you're sharing them in a Dropbox, you probably want to go with the FAT file system that both those operating systems can read. If you want to go NTFS, that might be fantastic for a Windows box, but not so great for a Macintosh trying to read that same exact file. So I'm going to say, nope, I don't have any files larger than 4 gig that I'm going to keep inside of this new volume. I'm going to click on Next, and it also gives me the option here of specifying NTFS, FAT, or none. I'm going to say FAT, and then I can also specify the cluster size. I'm going to pick the default of FAT, and I'm going to select the default cluster size. Now take a look at this. See this random pool here? As I move my mouse, it makes these move faster. So if you move your mouse, it just helps make that more random. So somebody can't guess, oh, you just created a TrueCrypt volume and this identifier that uses. I'm going to go ahead and simply move my mouse a little bit. It changes very rapidly. I'm going to click on Format. So I'm clicking on Format. It says, okay, here's the time left, about 7 or 8 minutes for that 10 gig on my external drive. Now, I'm not going to make you wait that entire time. What I'm going to do is I'm not going to I will move my mouse enough to pause the recording, and we'll come back exactly to this point when it's very close to the end of formatting this drive, because our next step, once it creates this huge file, this 10 gig file, we're going to go ahead and mount it as a logical volume. We can mount it as the X drive or the Q drive or the T drive, whatever we want. And when we mount it, it's going to require the password that we used when we created this logical volume to unlock it so we can actually write and read files back and forth into it. And as it finishes up, we're going to have this beautiful file sitting there called boring.mov on the F drive in the working folder, but it's not actually usable yet until we mount it. So I'm going to click OK on that. I'm going to say I'm done. I've created my volume. I'm going to exit out. The next step is to go ahead and mount it as a logical volume. So we go to the file system and we looked at that working folder. There'd be this 10 gig file. So if we just go to the file system just for a moment and we go to that F drive and we go to working and open it up, there's boring.mov. Now my Windows operating system has automatically associated .mov with some type of a media file. So that's why it's giving me this cool icon. But if I open it, first of all, it's not a media file, so it wouldn't play. And secondly, it's just an encrypted giant file. So we do a right click and go to properties. It's going to say, yep, this puppy is 10 gigabytes in size, and it's pretty much worthless to anyone until we mount it, and it's going to require the correct password to mount it. So at the moment, it's a giant 10 gigabyte blob, a big file that's encrypted that no one has access to, not even us, until we mount it. So let's go back to our TrueCrypt software, and we'll say, let's mount it as the X drive. That's available. These are all the drives that are currently not used by my system. And I want to say, you know what? I want to mount it as the X drive. It says, okay, what file do you want to mount? And we're going to click on Select File and pick that file from the F drive. So we go to the F drive and we go to Working, and there's our boring.movie file. And we'll simply say, I want to open that one or select that one. And then I can go ahead and click on Mount. And this is the secret that makes that file logically mounted as drive X. So we'll click on mount, and it needs the password. So if someone does not have the password that we use to create this encrypted file, they will not have the ability to see the contents or work with the data inside of this logical volume. So we'll put the password in. And it's thinking and cranking away, and now it's set. I now have a 10 gigabyte volume sitting logically as drive X on this computer. So if we bring up Explorer, there's drive X. We'll open it up, and it's got nothing in it at the moment, but anything that we put there is going to be written to this encrypted volume X. And then once it's dismounted, that data is not accessible by anyone. So if it's in a Dropbox folder or on this computer, it's going to be sitting, resting, if you will, in an encrypted form. Some things that we could store here would be things that are sensitive, that have sensitive information. For example, if you have password files that are just text at the moment, this would be a great place for them. So they're going to be stored in secret so that somebody who gets your data won't be able to automatically see what that password file contains. For example, let's say I have some configuration files that I want to keep very secure. I don't want people to steal them. So I could go ahead and I'm going to paste them into this folder, and I can work with these files. If I double click on one, it's going to bring up that data as it is. And these are just examples of some of the configuration files I have. This data, these 3 files, are sitting logically in volume X, and the entire volume X, really, if we boil it all down, is in this working directory, this one file called boring.mov, which if we went and hadn't dismounted that, or we rebooted, that file is just sitting there. It's just a file that no one can get into unless they have our password to decrypt the contents. And this is a great way of securing portions of our file system to plan for worst case scenarios where somebody maybe compromises our system or steals a computer. At least that way they won't have access to any of our volumes that we've mounted with a pretty good password through TrueCrypt. So one way of working with this is if we want to use those files in this logical volume, you mount that volume, you use the files, and when you're done, you simply go back to TrueCrypt and say, I want to go ahead and dismount the drives. It dismounts it, and then it's simply a file at rest, a 10 gigabyte file. And if we wanted to use it again, we'd have to mount it once again, supplying the password, and that protects that file at rest on our physical hard drive. In this nugget, we've taken a look at some common best practices, including using firewall software that's normally provided with an operating system, using some type of antivirus or anti-malware to help protect your system. We've also introduced the concept for a few of you regarding OpenDNS.com. That's a great way to make sure that when we're sitting at our computer and we're trying to go to site xyz.com, that we don't get redirected based on an incorrect IP address to hacker.com, who then makes the site looking like XYZ and collecting our information as we try to authenticate or log into the incorrect site. That's a great idea. I suggest everybody take a look at OpenDNS.com. And so that's a free one. It's super easy to implement, and all the details are up at OpenDNS.com. We also took a look at how to implement TrueCrypt, which is amazing. It's simply identifying a space inside of your file system where you want to create a brand new file, and this brand new file is going to turn into an encrypted volume that you can mount and dismount at will. Your homework, should you choose to accept it, is to download and install TrueCrypt. Create an encrypted volume. You can use all the defaults here first and create that encrypted volume so you can store your more sensitive data inside of that drive. Now check this out. How does this relate to Bitcoin? Well, the answer is simple. If we create a paper wallet with our private and public key information where we don't want anyone else to see it and we don't want to store it anywhere else, we could do one of two things. You can print it and keep a paper wallet. That literally is a paper wallet. Or we could take an image of that paper wallet and put it into an encrypted volume. And that would be secure there as well, as no one would be able to see that unless they had the password to mount that specific volume. Another benefit of using TrueCrypt is any sensitive data that we want to make sure that people don't get their hands on, we could store inside the encrypted volume for that added amount of protection. And lastly, if we're using Bitcoin, maybe we've installed the full Bitcoin client locally on our computer, which means we have our own wallet on our computer. We could also store that wallet inside of a TrueCrypt protected volume for that much more protection. I've had a fun time in taking a look at OpenDNS and using TrueCrypt to protect our systems. I appreciate you watching. I hope this information has been informative for you, and I'd like to thank you for viewing.